Hey everyone, welcome to lecture 3 for Six Sigma Black Belt. Today we are going to take on two topics. Number one is Six Sigma philosophy and the second one is Six Sigma as a matrix, methodology and management system. So let's take on with Six Sigma philosophy. Before I move on further, I would like to give you a brief overview of Six Sigma. Six Sigma has three different meanings. To illustrate this better, I have made a picture for you on the board, and if you can see, I have divided this pyramid in three parts. On the bottom is Six Sigma as a statistical tool, in the middle is Six Sigma as a process, and on the top is Six Sigma as a philosophy. When we talk about defects, cost, tools, plans, we talk of Six Sigma as a statistical tool. Here we use these tools to bring down the defects and errors in our products and services to a number which is 3.4 defects per million opportunities. Now let's take on Six Sigma as a process. When we talk about growth, transformation of an organization, we talk about Six Sigma as a process. Here we use DMAC process improvement model and DMAC process improvement techniques to bring down the defects and variation in our products and services. And finally, let's take on Six Sigma as a philosophy. When we talk about change in the thinking of the management, change in the working of the employees, and change as a whole, we talk about Six Sigma as a philosophy. According to Six Sigma philosophy, anything which is less than ideal has room for improvement. Since defects cost us money, so we should improvise ways, use methodologies and techniques to bring down these errors and defects so that we can get long lasting results and benefits. Any company cannot say that they follow Six Sigma philosophy or they work on Six Sigma principles until and unless they embrace Six Sigma as a whole. By this I mean they should embrace Six Sigma from top level management to the baseline employees. Everyone should work on Six Sigma philosophy, should use Six Sigma. Only then they can say that they follow Six Sigma philosophy. Let's move on further. There is a philosophical element associated with Six Sigma. The underlying belief is that the highest quality producer is the lowest cost producer. And allied with this belief is a concept that variation is the root cause of performance limitation. If we can remove this variation and produce products and services which are of right cost, which are defect free, error free, which last for expected period of time, then we would receive no customer complaints. And a happy and satisfied customer is a root and a foundation of strong business houses, and this also defines our Six Sigma philosophy. Now I would go back to my wording where I said that variation is the root cause of performance limitation. Why? If there is variation in our products and services, this means they are not of good quality, and this variation is not helping us to produce good quality products and services. It's a restriction in our quality. So with use of Six Sigma, we try to bring down the defects and errors in our products and services to a number which is 3.4 defects per million opportunities. So with use of Six Sigma, we try to achieve this number, and this is considered world class. Now you might be thinking that when we are using Six Sigma, then why we only need to achieve this number? Why can't we just completely remove this variation so that we have zero defect products? Okay, let me explain this in this way. Think that this A is any modern day process. There are number of factors which work on this process. Let me name them as A, B and C, and then there are noise factors. These noise factors are totally not in my control, and since this is a process A, and to reach Y, that is the output, this process has to go through number of steps. So it is very difficult to control all these factors plus all these processes. So whatever we get, we always get a variation instead of one single point production. With the help of Six Sigma, we try to reduce this variation and try to produce goods and services which are all in this acceptable range, which are between upper spec limit and the lower spec limit, and whatever is produced in this range is acceptable to the customer. So with the help of Six Sigma, we try to bring down this variation so that all our products and services are acceptable to the customer. The basic purpose of Six Sigma, or we can say that Six Sigma basically focuses on customers and stakeholders for whom the enterprise exists. And I must say this is a cause and effect mentality, because the purpose or the focus of Six Sigma is to make the customers happy and to bring up the profits, that is dollar. And this can be achieved by reducing variation. When we reduce variation from our processes, our products and services have lesser number of defects, and when we provide good quality products to a customer, he would be satisfied and he would stick to our business, which will bring long lasting profits and benefits to our organization. Ultimate goal of Six Sigma is to enable employees to deliver greatest value to customers and employers, and this can be done by application of scientific methods to design and operate business processes. Now the question is how you can apply the scientific methods. This can be done in 5 simple steps. Let me just give you a brief of all these 5 steps. Step 1 is observe and explore. Then comes step 2, it's develop a hypothesis. Then comes step 3, it's predict. Then comes step 4, it's experimentation. And finally, it's step 5, where you keep on repeating your step 3 and 4. Now let's go in with detail. In step 1, you observe your business and explore the market in which your business serves or which it intends to serve. In step 2, on basis of your observation, you develop a hypothesis. In step 3, on basis of your observation and hypothesis, you make predictions for your business and organization. And then comes step 4. This is a very critical and important step. Why? Because here you conduct experiments to see if your hypothesis is correct or not, and in case the result from your experiments vary from what you have put in your hypothesis, you should modify your hypothesis accordingly, and if still variation exists, then you should use statistical tools to find out the root cause of this variation. And then comes step 5. In this step, you keep on repeating your step 3 and 4 until and unless the results from your experiments and hypothesis are in complete harmony. After going through all these steps, you will have a detailed theory explaining the relationship between your business and market. And by applying these steps to your business, you can predict the future of your business and organization. So, by applying these scientific methods over a period of time, you will develop a deep understanding of what makes your customer and business tick, and this is the bottom line of Six Sigma philosophy. So, if I have to summarize Six Sigma philosophy, I would conclude that it focuses on customer number 1, number 2, it's centered around target or mean, and number 3, to reduce variation. Now let's take them one by one. The first one is focus on customer, or what is critical to quality. So if I have to start a Six Sigma project, I should know what my customer requirements are, and then I should devise ways to produce goods and services which might make my customer most happy or give him maximum satisfaction. That is key parameter, and Six Sigma philosophy focuses on this one. Then comes center around target or mean. By this I mean that when I am going on to do a Six Sigma project, I should devise ways and methods to produce goods and services which are closest to the target, that is, which are closest to my customer requirement. Here I would like to give you a mention of Taguchi's quality loss function. We have done this in a detail in our lecture 2, but here I would again give you a brief. So what did Taguchi said? Let me draw a figure for you first. So Taguchi said that if I produce goods and services which are closest to the target, this means which are closest to what my customer requirements are, I would have least losses and would have high profits. So I should focus on to make products, to produce goods and services which are closest to the target and in this customer tolerance range, that is lower spec limit and upper spec limit. And if I am able to do this, then I would have no losses and have maximum benefit and maximum customer satisfaction. Then comes third one, that's reduce variation or standard deviation. You all know that variation is the biggest enemy of any process, because due to this variation we have defects and errors in our products and services. So by use of Six Sigma, I should try to bring down this variation and produce goods and services which are in this acceptable range, that is within the lower spec limit and upper spec limit. So everything I produce, I should focus to produce in this range, because anything which goes beyond this is total waste and it won't be accepted by my customer. So I should try and focus on producing all my products in this range, and this can be done only by reducing variation. So finally, I would say that customer satisfaction is key parameter and all efforts are measured through it. Six Sigma focuses on customer. It's a very data driven and fact driven management, not at all based on belief. Six Sigma focuses on process improvement. It is a productive management, not a reactive management. Again, it's a boundaryless collaboration and it has drive for perfection. Let me take up them in a bit detail. So when I say Six Sigma focuses on customer, is that when I have to implement a Six Sigma project, I should take to notice what my customer requirements are, because his satisfaction is paramount to me and to my business. Then when I say that Six Sigma is a data and a fact driven management, what I mean to say is that Six Sigma is not based on belief. Nothing is left to chances. You only can start a Six Sigma project when you know what the end product would be like. So Six Sigma is totally dependent upon hypothesis, data. It's a very scientific technique. You cannot start a Six Sigma project until and unless you have good data, you have developed a good hypothesis. It will lead to a failure if you are lacking in your data and your hypothesis. Then Six Sigma focuses on process improvement. By this I mean is that Six Sigma tries to focus when the process is already on. It won't wait for the results to come out. Six Sigma would try to make amendments when the process is on, like it would see if its employees are working fine, they are trained or not, the raw material is good or not, because when all these factors are under our control, the end products would be good, it would have less defects. Same, Six Sigma is a productive management, not a reactive management. By reactive management, I mean is that I would take action only when the defects are already there in my products and services. So, Six Sigma is a productive management. This means it takes care of the inputs, that's raw material, the man force, the machinery, everything. Six Sigma takes care of them so that whatever is produced has lesser defects and lesser number of errors. Six Sigma is a boundaryless collaboration. This means it doesn't work on department-wise basis. Six Sigma works in an organization as a whole. We can only implement or start a good Six Sigma project when it's embraced by an organization as a whole, from top management to the floor line employees. Everyone is working on Six Sigma techniques. They are following Six Sigma methodology. This is how Six Sigma works. Finally, Six Sigma has a drive for perfection. Yes, the basic purpose of implementing Six Sigma is that to bring down the number of errors, to bring down the number of defects. But still, it has tolerance for failures, because if it knows where the failures are, only then it can improve upon them. Now, let's begin with part 2 of our lecture, that is Six Sigma as a matrix, methodology and management system. Whenever I think of this topic, or whenever this topic comes, there's one story which comes to my mind, and I would like to share it with you. This story is set in ancient times in ancient Asia, and most of you might have heard it, but still I am going to share it with you. The story is something like this, that there were a group of 6 blind men, and they were asked to touch an elephant. They had never seen an elephant before, so they had no idea of what they were touching. The first blind man touched the leg of an elephant and said that it was a pillar, a solid big pillar. And the second one touched his tail and said no, that it was just a rope, nothing else. The third one touched his ear and said that it was a big fan. The fourth one touched his tusk and said that it was a solid pipe and nothing more than that. And the fifth one touched his trunk and said that it was a branch of a tree. And finally, the sixth one touched his stomach and said that you are all fool, it's nothing but a wall. So what we get to know from this story is that each of them were correct from their individual perspectives, because 1, they were blind, and 2, they had never seen an elephant. So whatever they were concluding was what they had just thought it was. Same is the case with Six Sigma. Some people think that Six Sigma is a matrix. For some, it's a methodology, and some consider it as a management system. But the best approach to understand Six Sigma is understanding that all of these 3 coexist, and one is based on the another. To help you clear out this process, I've just drawn this picture for you on the board. Here, if you can see, in the core, it's Six Sigma as a matrix, and then in the middle it's methodology, and on the crust it's a management system. Okay, when we talk about measuring process variation, using statistical tools, bringing down defects and so on and so forth, we are talking about Six Sigma as a matrix. When we talk about using of DMAC as a process improvement model, team-based problem-solving techniques, measurement-based process analysis, improvement and control, then we are working on Six Sigma as a methodology. And finally, when we take Six Sigma as Six Sigma driven strategy execution, leadership, sponsorship and review, because all Six Sigma projects need a good sponsor and they should be reviewed properly. Matrix driven governance processes are in place, and the most important, engagement across organization. Then we talk of Six Sigma as a management system. But if you think that it's just a matrix or a methodology or a management system, it won't be full perspective. It will be only incomplete, it would be half, because each of them completes another one. Now let's take them, each of them, in a bit detail. First, let's start with Six Sigma as a matrix. As discussed earlier, Sigma is the measurement used to assess process performance and result of improvement efforts. In simple ways, if I have to say, it's a way to measure quality. With help of sigma, we can measure quality of any process or product. Now the question arises, why businesses use sigma to measure quality? This is because sigma is a standard that reflects degree of control over any process to meet the standard of performance which is set for that process. Now, if I have to explain you in a simple words, it's a universal scale. Like we use thermometer to measure temperature and yardsticks to measure inches, in same way we use sigma to measure quality. So, with sigma, we can compare different business processes in terms of a capability of a process to stay within a quality limit established for that process. Now, let me introduce you to sigma scale. If you can see this diagram, it looks a lot like a thermometer. On my left hand side, these are sigma levels, which you can see 3, 4, 5, 6 and 7, and on my right are defects generated in these levels, the defects generated per million opportunities. Now, if you can see closely at 3 sigma, the number of defects which are generated are 66,810. At 4 sigma, number of defects which are generated are 6,210. At 5, they are becoming little less, like it's just 233. And at 6 sigma, we are generating 3.4 defects per million opportunities. This is a very critical or a crucial number, because right now, if any process is working at 6 sigma level and generating 3.4 defects per million opportunities, it is considered a world-class product from quality perspective. Same way, if we go higher like 7 sigma level, the defects which are generated are only 0.002. So, defects are becoming less as we go up. So, now the question is, what does this sigma scale does? What does it basically do? Sigma scale measure defects generated per million opportunities, or we can say it allows us to compare the defects generated by various sigma levels. Now, I would like to elaborate this further. Let me tell you that if any process is working at 4.6 sigma level, this means it is working at an efficiency that is 99.9% efficiency. But I would like to tell you that it's not enough for certain processes. You might be thinking that I've gone crazy because 99.9% is a good number, and if any process is working at this level, this means it's totally error free. It should be an error free. But before you make any conclusions, let me give you few examples. Okay, if a process is working at 4.6 sigma level or 99.9% efficiency, then defects generated are, okay, if it's a medical field, then 4,000 wrong medical prescriptions per year. 3,000 newborns would be dropped by doctors each year, and if it's a postal department is working at this efficiency, then it is 400 letters lost per day. Now tell me that would you trust these services? Would you go to such doctors if your wife is pregnant? Would you go to such doctors who can drop your child? Or would you go to such doctors who would give you wrong medical prescription? You would say no. This means we need to raise our bar. We go to higher sigma levels. So if same processes work at 6 sigma, this means their level of efficiency would be 99.9997%. And if they are working at 6 sigma, then these number of errors would be dropped. For example, there would be only 13 wrong prescriptions each year, only 10 newborns will be dropped, and only 1 letter would be lost per day. This number now sounds good. But now I would also like to add that it's not always important that if a process is functioning only at 6 sigma or higher level, only then it's good enough. No, because there are certain processes which are running smoothly even at lower sigma levels, and some need even higher sigma levels than 6 sigma. For that, I would like to give you few examples. For example, take an example of IRS phone in tax advice. It is running quite smoothly at 2.2 sigma level. Then comes airline baggage handling. It's working good at 3.2 sigma. Best in class companies who are producing quality products, quality services, they work at 5.7 sigma. Now comes a digital watch which is working on 6 sigma, and we all know that it has great efficiency. It just takes 1 second off within so-called 31 years, and this is a best, like a best example of 6 sigma. Then comes airline industry fatality rate. It needs even higher sigma levels, and it is working at 6.2 sigma. So, we can conclude that sigma as a scale helps us to measure and set quality goals for our business processes. Let's start with 6 sigma methodology. 6 sigma, as I told you, that 6 sigma matrix, methodology and management system, all of them coexist. Same way, 6 sigma methodology is based on 6 sigma matrix. DPMO, that is defects per million opportunities, is used to measure and assess process performance. DMAC methodology is applied to analyze the process and find solution to unacceptable variation, and an effort is made to eliminate errors and variation. Now, DMAC process improvement model is a very important part of 6 sigma, because every 6 sigma project has to go through all these 5 steps, only then it can be implemented successfully. In this lecture, I would just give you a brief of what DMAC and what other statistical tools are used in 6 sigma. So, to begin with DMAC, it is a 5-step or a 5-phase approach. D stands for define. In this phase, you define the goals of your improvement efforts, that is what you want to achieve. Then comes measure. Here you measure your existing system of its faults. Then comes analyze. This means you analyze that what are the errors in your system and how you can achieve your desired goals. Then comes improve, which means that you use improvement tools or statistical tools to improve your system and eliminate errors. And finally comes control. This is also very important, because if you won't put control in place, this means your system will fall back to its previous working style, and again the products will show or the services will show up errors. But never think that DMAC is the only approach or only methodology which is used in 6 sigma. There are other tools as well, such as TRIZ, Lean, Ford's 8D, 5 Whys and root cause analysis. All these tools along with DMAC, when come together, form a perfect 6 sigma scenario. In this lecture, I would just give you a brief of all these tools, but in our future lecture series, all these tools will be explained in great length. So, let's first take up TRIZ. What is TRIZ? TRIZ is a problem solving, forecasting and analysis tool. It is derived from the study of patterns of invention in global patent literature. If I have to give you certain important facts about TRIZ, then TRIZ is devoted to revealing patterns of evolution, and one of the objectives of TRIZ is to develop an algorithmic approach to the invention of new systems and refinement of the existing ones. Lean is a managerial concept. Lean and 6 sigma are combined to target and remove 8 kinds of waste, which are mainly defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion and extra processing. I can give you one term with the help of which you can remember all these 8 kinds of waste with an ease, and that one word is downtime. Each alphabet of this word will tell you about one waste. So, let's take up all these waste in a bit detail so that you have an idea of how Lean and 6 sigma combine together and remove them. The first one are defects. Products or services that are not up to the specification, you know, they cannot be sold. This means resources are required to correct them so that they can be sold. Then comes overproduction. This is that kind of waste that's producing too much before we are ready to sell our products. This means whatever is being overproduced will go waste, and obviously waste is loss. Then comes waiting. This is the time when we are just simply waiting for the previous steps in a process to finish so that we can begin with the new one, and whatever time is wasted, this means our resources are being wasted. Then comes non-utilized talent. Okay, all the employees that are not effectively engaged in the production, this comes under non-utilized talent, and this is a very big waste and it should be controlled, because we should efficiently use our manpower. Only then we can control the wastage in our processes. Then comes transportation. That's transporting items or information that are not required in a process from one place to another. So with this we are just wasting our time and money, and it also comes under wastage. Then comes inventory. This means non-utilized information or inventory which is just lying idle. Then comes motion. This means unnecessary movement of people and things due to maybe totally wrong or misplaced workplace, or just when they are just wasting time to find out the misplaced items. All of this comes under wastage. And then is extra processing, that is performing any activity that is not necessary to produce a product or a service. This means whatever resources are gone into this extra processing are being wasted. So with help of Lean and Six Sigma, we try to target and remove these all these 8 kinds of waste so that we can improve our products and services. Let's begin with Ford's AD. D stands for disciplines, so basically it's Ford's 8 disciplines. Ford's AD is a problem solving methodology, and it is used to approach and resolve the problems. It's used by quality engineers, and its purpose is to identify, rectify and eliminate reoccurring problems. This technique is very useful in product and process management. Ford's AD works on a PDCA logic. Now you would think that what is PDCA? PDCA is a continuous quality improvement tool, and it stands for plan, do, check and act. And like any cycle, PDCA is a never ending process if a process is running on quality improvement lines. Let's take up all these 8 steps in a bit detail so that you have a brief idea of how Ford's AD will help you to resolve the problems. So the first step is plan. Obviously, if you have to start any project, you would first plan. You plan for solving the problems and determine the prerequisites, that what would be your requirements and how you would go through this process. Second is use a team. Obviously, after you have a plan, you will choose your team, that is, establish a team of people with product and process knowledge, because this is the team which will help you to identify and resolve the problem. Then comes specify the problem. Now you have plan in hand, you have your team, so the first job of team is to specify and define and describe the problem by identifying it. Then comes you develop an interim containment plan. So you verify and implement interim actions and try to isolate the problem from the customer. Then comes D4, that's identify and verify root causes and escape points. So here in this step, you will try to identify all applicable causes, and you would try to explain why the problem has occurred, and you will also try to find out the ways that why this was not noticed earlier. So this is done by brainstorming and use of statistical tools like Ishikawa diagram. Ishikawa is also known as fishbone diagram. So with the help of this diagram, I will just give you a brief explanation of this one. What is an Ishikawa diagram? So basically, now the team will find out all of possible causes through brainstorming, that why the problem has already occurred or why the problem was there. So this is the fishbone diagram, and this is our problem. So now the team will find out all possible causes that would have caused this problem. For example, A, B, C, D. So this looks a lot like a fishbone, and so it's also known as fishbone diagram. So now the team has all of the possible causes that what would have caused the problem. So now they will work on each of these causes and try to figure out and single out what actually caused this problem and where they need to work. Then comes, you need to choose and verify permanent corrective actions for problem and non-conformity. This means you will have to find out permanent ways through which, like pre-production methods and programs, and make sure that by using which corrective action you would ultimately resolve the problem. Then comes implement and validate corrective actions. So you define and implement the corrective actions you have used to resolve the problem. Then you take preventive measures. Okay, this is also very important. Now you have just found out what has actually caused the problem, you have resolved the problem. So now what you need to do is you need to put checks in place, you need to put on preventive measures so that the system does not fall back and the problem does not resurfaces again. Then finally is the step 8, that's known as congratulate your team. So you have to recognize the corrective efforts made by the team, and the team needs to be finally thanked by the management and organization. Let's take on 5 whys. 5 why is an iterative question asking technique which is used to explore the cause and effect relationship underlying any particular problem. Primary goal of this technique is to determine root cause of a defect or a problem. This means that by using this technique, we can exactly find out what is the root cause and what exactly is the element which is causing the problem. 5 is the name derived from empirical observation or number of iterations typically required to resolve the problem. To help you understand this better, let me give you an example. It is a very simple and a basic example of a 5 why technique, and once you have just gone through this example, you will understand that how this is a simple technique but a very effective one. So I am just giving an example that I discover a coolant is leaking from a machine. So now I just need to find out the root cause of why this coolant is leaking, and now I am going to use my 5 why technique to find out what is the root cause. So my first question would be that why the coolant is leaking. So I will conduct some tests and make some observations to find out that why this coolant is leaking. So I would find out that the seal on the coolant wall is damaged. This gives answer to my first why, that why the coolant is leaking, because the seal is damaged. But now again this becomes a question that why the seal on the coolant wall is damaged. What has damaged the seal? So again I will try to find out the answer to my second why, which is that metal shaving got into the coolant. Now I got the answer to my second why, that why the seal was damaged, because there was a metal shaving in the coolant. Again this forms my third why. This gives answer to my second why, but in itself it's a question that why this metal shaving got into the coolant. So I need to find out the reason for this. So I would again conduct some experiments and make some observation and find out this metal shaving got into the coolant because the screen on the coolant regulating pump was broken. So this is the reason, because the screen was broken, this is why the metal shaving got into the coolant. Now this gave an answer to my third why, but this has become a question again. So to find out, I will again use some experiments and find out that why this screen was broken. So I find out that the screen is located at a place where it was likely to be damaged by the dropped parts. So now this is also the root cause. Now I found exact answer to my problem, that why this coolant is leaking, because the screen is located at a place where it was likely to be damaged. That's why the coolant was leaking. So since this gave my root cause, I would also be able to find solution to this problem. So after going through all these 5 whys and finding out the root cause, I just found out the solution. Right now, two solutions are coming to my mind. The first one is I can redesign the machine. This is a tedious one, a lengthy one, and a difficult one. So I would like to do something which will resolve the problem, and so the second solution which I have is I add a guard to the screen and cover it properly. So when I do this, this will help me resolve the problem, because then my coolant won't be leaking. So with the help of 5 why technique, which was a very simple technique, I was able to find out the root cause of the problem, and also I was able to find out the solution to my problem. So now you can see that by use of consistent set of metrics such as DMAC, TRIZ, 5 whys, 4s, 8 Ds, and other root cause analysis, etc. and etc., an organization can understand and control their key processes. And when any organization can better understand their key processes and control them, they will deliver better quality products and services. Here I would sum up my Six Sigma methodology, and I will move on to Six Sigma as a management system. Let's begin with Six Sigma as a management system. Six Sigma should not be and is not limited to and should not be considered just as a matrix or a methodology to solve problems, because Six Sigma is a management system, and continuous business improvement is only possible when any company's top level management embraces Six Sigma. Six Sigma as a management system encompasses both Six Sigma as a matrix and Six Sigma as a methodology. And breakthrough improvements can occur in any organization when its top level management adopts Six Sigma. The best example I can give you is of Jack Walsh, CEO of General Electric. He not only attained complete knowledge of Six Sigma, but also made sure that his top level managers are trained Six Sigma professionals. So, Six Sigma as a management system focuses on understanding and managing customer requirements. As told many times, customer requirements and customer satisfaction is paramount to Six Sigma projects. Whenever a Six Sigma project is started, it's always thought about that what are the customer requirements, because only when the customer is satisfied, the company will bring in the profits. And so after managing customer requirements, all the key processes are aligned to achieve those requirements. And to achieve these requirements, rigorous data analysis is used to understand and minimize variation in key processes. Six Sigma is not at all a hypothetical subject. It's very practical, very scientific. It uses statistical tools and rigorous data analysis tools to find out the reasons why there is waste and errors, and using these techniques, it removes those waste and errors. And finally, driving rapid and sustainable improvement to business processes. So, when Six Sigma is embraced by top level management, there is rapid and sustainable improvement to the business processes. So, what I can say here is that Six Sigma is a unique way of thinking. And believe me, any company can achieve great results if they are using Six Sigma, and if their top level management is embracing Six Sigma, they can bring unimaginable profits and benefits to their organization. If I am asked to summarize Six Sigma management system, I would say that it is huge and designed to guide an organization's performance improvement initiative at all levels. This system is built on BPM organizational structures. BPM is business process management. Six Sigma treats business processes as its fundamental building blocks, and business process is an operational unit that is measured, managed, and continuously improved using Six Sigma. Based on high performing ethical leadership and team involvement, and finally team based model is its fundamental work unit. So now I can conclude that Six Sigma focuses on three main constituents, and these are customers, shareholders and employees. And change in Six Sigma is managed by changing people's thinking, changing norms and changing systems and processes. So, purpose of Six Sigma management is to create a strategic business improvement approach that seeks to increase both customer satisfaction and companies' financial health. Finally, I would like to say that Six Sigma improves bottom line profits by reducing costs of hidden poor quality, and its goal is to achieve Six Sigma level of quality by increasing efficiency of its processes and profitability. Let's study differences between Six Sigma and traditional management. The differences between Six Sigma and the traditional management approach are profound, but here I have taken the two major differences. So, according to traditional approach, it is only applied to manufacturing processes, whereas Six Sigma is applied to all important business processes. Then the second major difference is that according to this approach, a capable business process is one that has a process standard deviation of not more than 1/6 of the total allowable spread, whereas Six Sigma requires process standard deviation of not more than 1/12 of the total allowable spread. So, the major points which we have to consider regarding these two differences are that Six Sigma addresses all business processes and it treats manufacturing processes as part of a larger system. Why? Because the customer is not only concerned about how the product is manufactured, but other factors such as what is the price of the product, when is it updated regularly or not, is there any technical support available or not, and if there is financing terms available or not. Other factors are also important. So, this is why it treats all business processes and not only on, it does not just focus on the manufacturing processes. So, Six Sigma removes narrow inward focus of traditional approach. Moreover, Six Sigma benefits have deep impact on all parts of the organization. Its broad scope means that it provides benefits to all stakeholders in the organization. That is why Six Sigma is better than the traditional 3 or 4 Sigma approach. There is one more difference which I would like to bring to your notice, is that in contrast to Six Sigma quality, 3 Sigma quality standard of 99.73% translates to 2700 defects per million opportunities, even if we assume zero drift. And for a process with series of steps, the overall yield is a product of yield of different steps. I will explain this using example. Consider a step or a process that has 2 steps. Okay? So, step 1 has a yield of 90% and step 2 has a yield of 80%. Now, what will be the overall yield of these two or this process? The overall yield will be the product of these 2 steps, that is, let me calculate it for you. Which would be or 72%. So, now you can see that this yield for step 1 was 90% and the yield of step 2 was 80%, but the overall yield is 72%. This means that the overall yield of this process which has series of steps is always less than the yield of the step which has the lowest yield. If 3 Sigma quality levels of 99.97% yield are obtained from every step, and if the process has 10 steps, then the quality level at the end of the process will have 26,000 defects per million opportunities. Now you can very well imagine why Six Sigma application is mandatory and not just optional. Now I would give you a brief summary of Six Sigma approach. First, it is a data driven approach. For this I will just give you one formula, that is y is equal to fx. Y is output and x is input. In a data driven approach, you see effect of process input on process output. So here if I have to tell you that x is always independent but y is dependent, y is dependent upon x, then x is input and y is output. So if we have to control our output, we have always to work on our inputs. Then x are the causes, y are only the effects. This means if we need to eliminate some defects, we have to work on the causes, effects would go by themselves. Same way, x is a problem and y are only the symptoms. Again, if we have to remove, if we can remove the problem, the symptoms will go by themselves. And finally, we have to control the x, and then we don't need to monitor y, but otherwise x can be controlled but y can only be monitored. Then Six Sigma is a project oriented approach. This means it's focused on customers and profits. Then its project selection is tied to organizational strategy. This means it doesn't focus on individual departments but on organization as a whole. Financial reporting system is in place, and lastly recognition and reward system. This means financial benefits are calculated and recognition is awarded to those who have successfully implemented Six Sigma projects. Here I would wrap up my lecture 3. For more information on Six Sigma and to get Six Sigma certification, visit brainmeasures.com.